Hi, I'm Grace Moeller from Moeller County New Horizons 4-H Club, and this is my plant sciences project on dyeing with Persea Americana. So recently, as I've gotten older, I've been super interested in the fashion industry, and one of the biggest parts of the fashion industry itself is fast fashion. Fast fashion is responsible for 10% of the world's carbon emissions, and that is 1.7 billion tons of CO2 put in the air per year. Another issue with the fast fashion industry and why there's so much CO2 being put into the air is because of polyester fabrics. Polyester fabrics are made from things like fossil fuels and oils, which come from natural gas, which ultimately produce more CO2. Along with that, when you wash those polyester fabrics, that's releasing about 500,000 tons of microplastics into the ocean each year. And one of the biggest problems within the fast fashion industry is going to be the dyeing of the fabric, the dyeing of the polyesters. It's the second largest water polluter, and it accounts for 17 to 20% of the world's wastewater, and it's especially potent in Southeast Asian countries like Vietnam, India, and Malaysia, where a lot of clothing is produced. So my question became, how do different pH levels of the Persea Americana dye affect color? The Persea Americana dye is made from avocado seeds. So what I did was I decided I'll create the avocado dye and I'll put it together and I'll put it in some fabric and I'll switch up the pH of some different batches and see what color I end up liking the most. So my hypothesis was that the more acidic the dye bath is going to be, the lighter the color, and the more basic the dye bath is going to be, the muddier the color because of more things in the actual dye bath. So day one, I decided to go and get some avocado pits from my local Mexican restaurant, just from their used guacamole, and I went home, I got about 30 of them, I rinsed them off in the sink, and then I put them into a large stock pot, just like one I've used for making soup at home on my free time. I added enough water to cover the pits, and then I brought the water to a boil. While the water was boiling, I also soaked the fabric that I was going to dye. Once the water was boiling, I reduced it to a simmer, and I let it simmer for 30 minutes, and then I took it off the heat and let it rest overnight. When I came back the next morning, I took the pits out of the bowl, out of the stock pot, and I skimmed off all the debris, which would just be a little bit more of the avocado bits and some of the skins of the layers of the seed. And then I divided the dye into 4 different treatment jars. I added each treatment to its jar, and the treatments I used were iron filings, sodium bicarbonate, which is baking soda, and acetic acid, which is just vinegar. So after I wet the prepared fabric, I added the fabric to each treated dye bath. I brought the dye bath and the fabric back to a simmer for 30 minutes, and then I took it off the heat and left the fabric and the dye just on the counter for 4 more hours. After those 4 hours were up, I removed my fabric and rinsed it off and let it dry. So then, the third day, I went into school and I went to our chemistry lab and I brought the dye jars with me, and I put in I did 3 different tests. I did one with liquid indicator, I did one with Hydrogen papers, and then I did one with litmus paper. So with the iron filings, my main problem throughout the entire experiment is this dye got way too dark, and I couldn't tell if in the indicator it was changing color or if it was just making the strip dark. So for my sodium bicarbonate, or my basic solution, I got a purple with the universal indicator, which put it on about a 10 on the pH scale. And then with the pH paper, it gave me about a 9. And then for the blue litmus, it turned blue, which means it was basic, and red litmus, it turned blue, which also meant basic. For the acetic acid, or the vinegar, I got orange on the liquid indicator and orange on the pH paper, which put it on the pH scale at about a 5. And then on the blue and red litmus paper, I both got pink results, and pink equals acidic. And then for my control one, the universal universal indicator just made it just a little bit darker, and then with the pH paper there was no change. Obviously the blue litmus, it turned a very, very, very light blue, which means it was just the slightest bit basic in its natural state. And then for the red litmus, it also turned purple, which means it was just basic in its natural state. So in conclusion, the dye bath pH did not directly correlate with my color predictions. In fact, it was reversed. Baking soda, a base, actually produced the lightest color and also softened the fabric a little bit, which I thought was really interesting. That's all for my project. Thank you for watching.